In our last section, for section 8.2, we'll discuss graphing polar equations. Let's begin with this example. Sketch the graphs of the following polar equations. Our first equation is r is equal to 3. In order to graph this, we want to do a table of values, similar to what we would do in an algebra class. Recall that in an algebra class, if we were graphing an equation, we would do a table of values that had x's and y's. Because our equation is in polar form, instead of having x's and y's, we're going to do a table of values that has r and theta. Now, what you want to realize here is that regardless of what angle you pick for theta, the r value is always going to be 3. So, for example, if my angle was pi over 2, the corresponding r value is 3. If my angle was pi, the corresponding r value is 3. If my angle is 3 pi over 2, the corresponding r value is 3. And we could continue along this same path indefinitely. So you want to remember that if r is equal to 3, it is always equal to 3, regardless of what your angle is. Once we have a few points, we can go to our graph and plot those points on the graph. You will see that as you do that the graph forms a circle of radius 3. Our first point was pi over 2, which is here, and had an r value of 3. So here's our angle pi over 2. Going up 3 units, we would have a point here. Our next value was 3, and the angle was pi. So here's our angle pi, straight across. 1, 2, 3 on the terminal side, and we would have a point here. The last point that we came up with was 3 pi over 2, which is this angle. On the terminal side coming down 3, we would have a point here. And again, if we do that for enough points, we can see that the points connect to form a circle of radius 3. For our next equation, we'll do a similar process. We're going to set up a table of values. This time we want to realize that our angle is always 2 pi over 3. So if the r value is 1, the angle is 2 pi over 3. If the r value is 2, the angle is 2 pi over 3. If the r value is 3, the angle is 2 pi over 3. So regardless of the r value that we choose, the angle is always 2 pi over 3. So again, we can take this to our graph, we can plot our points, and we see that the graph draws a line. So 2 pi over 3 is this angle here. And so we have on that terminal side, we have a point at 1, we have a point at 2, we have a point at 3. And again, connecting those points, we can see that the graph draws a line. Now, as the equations become more complicated, for example, sketch the graph of the equation r is equal to 2 cosine theta. This is an equation that has both an r and a theta in it. We have several options for forming our graph. We can do a table of values as shown in the picture below. And so you would pick values for theta, you would plug them into the equation, and you would get the r value. So for example, if I were to pick pi over 4, just to look at one of these, I would plug pi over 4 in for my theta value. I would then say to myself that cosine pi over 4 is square root of 2 over 2. That's either a memorized value or something from my chart of exact values. The 2's would cancel, and the r would be square root of 2. And so I could continue in that manner, forming a table of values, and then plot those points, and I would come up with an equation that looked like this. So that is one option for graphing a polar equation, is to do a table of values, plot your points, and connect your dots. Another option for graphing a polar equation is to convert the equation to rectangular form. So we could take our equation r is equal to 2 cosine theta. And we could take that equation and we could multiply both sides of the equation times r, which would give us r squared is equal to 2r cosine theta. Then we could recall that r cosine theta is the formula for x. And we also have a formula for r squared. R squared is equal to x squared plus y squared. All right, so I'm just going to write these formulas down so we can follow what's happening. So we have this formula that we're using for r squared. And we have this formula that we're using for the x. And so plugging that in, we would have x squared plus y squared is equal to 2 times x. We could subtract the 2x from both sides. Which gives me this, x squared minus 2x plus y squared. We could then complete the square. So completing the squares on the x's would mean that we're adding 1 to both sides. The y does not need to have the complete the square process done because it's already finished. And then we could factor the x squared minus 2x plus 1 into x minus 1 times x minus 1. So this is the equation of a circle with center 1, 0 and radius of 1. So this is an option as well, although it's pretty heavy on the algebra skills. The third option that we have, and probably the way that we want to go in most of these cases, is to use our calculator. So we're going to talk about that as we get into some other examples, how we graph these polar equations on the calculator. Now, the polar equations can graph several different shapes. So I'm going to show you these first, and then we're going to look at how we use the calculator. So polar equations can graph circles and spirals. So we can have this type of graph. We can have these type graphs. We can have graphs that look like these. And graphs that look like these. We're not going to worry too much about the different types of equations because we are going to be doing it simply on the calculator. All right, so let's look at how this works. So we want to sketch the graph of r is equal to 2 sine 3 theta. So I'm going to go to my calculator and I'm going to turn my calculator on. And we're going to press our mode key. And we're going to change the fourth line using our arrows to polar. So POL, we want to highlight that and press enter. Then when you press your y equals key to enter a graph, you should see that the graph screen changes from a y equals 2 to an r equals 2. So I can go ahead now and type my equation in, 2 sine 3 theta. Notice that we're using the x key for the theta. And close the parenthesis. You do want to graph this in a trig window, so we're going to do zoom, option 7. And press enter. And you can see that the graph appears on the calculator screen. Let's try another one. Sketch the graph of r is equal to 1 plus 2 cosine theta. So let's go back into our y equals screen. Let's clear out the old equation and let's type in the new equation. 1 plus 2 cosine theta. We'll press the graph key and we can see the new equation being drawn.